Okay, so for this final video, we are going to talk about what the second derivative will give us. So we already have found the critical number. We used the first derivative to find the critical numbers. To use the first derivative test, we found roads where it has a relative max, where it has a relative min, where it's increasing, decreasing. And so the next thing that we're going to use is the second derivative, and that will tell us about, the second derivative tells us about points of inflection, and it tells us about the concavity. So concave up and concave down, where that's happening. So here we are going to, use the second derivative to find this information. So the first thing we need to do is find the second derivative. We're going to set the second derivative equal to 0 and solve. Okay, so what this gives me, notice whenever I set the first derivative equal to 0 and solved, I got a critical number. What this is going to give me is a possible point of inflection. So that might be a point of inflection, just like my critical numbers may have been my relative max or min. So point of inflection is where it changes the concavity. It goes from being concave up like this to concave down at that point, or it switches from being concave down to concave up like at that point. And so those would be points of inflection. So what we're going to do is we're going to use the second derivative to try to, we're going to make a sign chart just like we did with the first derivative. And we're going to try to determine if it's concave up and concave down and if it's switching. So let's go ahead and draw our number line here. And this time we're going to work with the second derivative on top. And we're going to put our point of inflection here, or our possible point of inflection. Right here is where the second derivative is equal to 0. And we're going to do the same thing that we did last time. We're going to just test each interval. So we're going to test a point from here, which we could choose anything to the left of 5/2. So I'm going to go ahead and choose x equals 0. And then we're going to choose something to the right of 5/2. So, I'll just choose x equals 3. Okay, so then we're going to plug that in. Remember, we're working in the second derivative column, so I'm going to plug that into the second derivative. So if I plug in my 0 here, and then I just want to know, what do I get back? What sign do I get back? This will be a -5, so it'll be less than 0. So this is going to give me a negative. And now I'm going to plug in my 3 that I chose to test. That's going to give me 6 minus 5, which will give me a 1. So that's going to be positive. And so what does this information give me? Remember, first derivative tells me about increasing, decreasing. Second derivative tells me about concavity. So this is going to be shaped down like a frowny face because it's negative. And whenever it's positive, it's going to be shaped up like a smiley face. So I remember that. Negative, you're frowning. Positive, you're smiling. So here we see that the concavity goes from it's down to up. So it does switch, which means that x equals 5/2 is an inflection point. So whenever x is 5/2, we just need to plug that into the original. To get what the point is. We know the x, but we have to find the y. Okay, so if we factor out here, we have 5/2 happens, 3 times here, twice here, and once here. So we can factor out 5/2 there. So let's pull out a 5/2. And then we have 1/3 times, and then we have 25/4 because we had 5/2 squared minus, again, 25/4 because we had a 5/2 squared left there plus 4. So that is going to give us, we have 25 over 12 minus 25 over 4 plus 4. So if we use 12 as the common denominator, we're going to get 25 minus 25 times 3 plus 4 times 12 over 12, which will give us negative 5 halves, or 12ths. So our point of inflection is going to be 5 halves and negative 5 over 12. So that will be the point of inflection. And our concave up, concave down intervals. So if you see, if we do concave up here, it's going to be on this interval starting at 5 halves up forever. So it will start at 5 halves and go to infinity. And our concave down, sorry, I'm running out of room here. Okay, our concave down will be in this pink interval where it starts at, forever to the left, so negative infinity, and goes up to 5 halves. So that is everything that we can determine from the first and second derivatives. So, in summary, we have that it's increasing up to 1, and if we look at our graph, we can see that it matches the information that we found. So we found that it was increasing all the way up until we got to x equals 1, which we then had a relative max at x equals 1, which is what we see here. And then it started decreasing until we got to x equals 4 right here, and then we got a relative min at x equals 4. And then it starts increasing again on forever, and we see that the points of inflection, it switches around 5 halves. So right here, you can see that it switches from going down, concave down, about at this point right here, it switches and it starts going concave up. So that is, the series. I mean, I just did several videos where we determined how to find out information about a graph from the first and second derivative.